All right, let's get started. So back to where we were and what we're going to look at today. So prior streams, we were able to get one single server thread spun up. We're listening on a server socket channel, and we are currently accepting any new connections that come in. When we accept that connection, we add an attachment to it, which we're calling client ID, and it's just a identifier for us that we'll use probably later down the road. And it's just the address and the port that it's incoming. Now, one thing I did last time that's actually wrong is we used the port and we said local port. We actually don't want local port. Local port is actually the port on the current machine that it's using, right? So that's not what we want. We want the actual remote port, because in theory we could have multiple connections from the same machine or same IP address, and so we definitely want this to be port so that it keeps track of all the different remote connections, right? So then we make that client ID and we register that client ID as a read, and then we had a client that we could basically just naively send hello server, and this server would read that in. Now, there's a couple problems with this this implementation the way it currently is, and I want to talk through that a little bit. So we basically have one current server thread that runs, and it's basically just this while loop, and it says accept any new connections and then attach ID to that connection. Our current implementation, however, also registers for read events, and then it says if it's readable. In the last stream we showed that we could read that data off, right? So what's the problem with this? We might get a very large read event. So say someone's streaming a file to us, and in that case we might read a pretty large chunk of it, we might read a small chunk of it, we don't really know. And in that case, we're actually blocking while we read, and that's preventing any new connections from coming in. So in some cases, that may be bad. In a lot of cases, it might be fine, right? Again, what we're doing here is multiplexing. So again, we're accepting any new connections. You could just write a very naive loop, and this would work fine for a lot of scenarios where you just say accept, read, and then do any writing that you need to do, right? So that's a very simple loop. It'll work, won't have any problems until you start maybe getting into some strange scenarios with maybe it takes a really long time to read. Maybe there's some latency and it takes a really long time to write. There could be all sorts of different problems. So what we're going to do here is we're actually going to move the read over to a different thread. So this server thread has its own selector, right? So this has basically an accept selector, and what that means is basically we've said the selector that we have that's in this server thread, we're registered to receive accept events. So this selector, whenever we ask it to select, it will give us only things that are in the accept state. And what we're going to do is we're going to basically put a read selector on a second thread, or a read thread, and when instead of registering to read on the current selector here that's in this server thread, we're actually going to tell it to register on read selector. All right. And so what does that do for us, right? So basically this allows us to kind of separate our thread and our operations. So this server thread, all it's responsible for is accepting new connections. And then this read thread is only responsible for, say, reading and buffering items, okay? So let's go ahead and do that. So just to real quick demonstrate where we are. So we have this server. We can run this server. Client is ready for read. So we can run this server. It spins up and sits and accepts connections. Okay, so we're listening on 10.03.1. When we spin this client up, we're going to get a accept connection. It's going to be accepted, and then we're going to see the client's going to send hello server, and what we'll see is we'll see the client ID is ready for read. Now again, we're not going to pull the bytes off the socket. We did that and showed that in the last stream, but we're going to extend this to make this better, right? So let's go ahead and run this. And so that ran and finished. And then what you'll see is this is spinning saying it's ready for read, right? Because we haven't actually read or pulled anything off, but you can see that we get that connection, right? So, okay. All right, so we are going to get rid of any reading on this thread because we're going to create a new one. Okay. And we'll just put this in a separate file just so it's easier to follow. Server reader. And I'll split this so we can take a look at the server. So this is going to look, this thing is going to look really similar to what we had. We're going to call it server reader. It doesn't need to take anything in, and it's also runnable, right? And we can put its implementation in here. Okay. Now, what does this thing need? So this thing needs its own selector. Selector. And we are going to just create this. And we're going to leave that as is, and we're going to write our thread here that basically says while not thread dot interrupted, and we're going to say selector dot select. We're going to give it a timeout just like we did in the last one. Again, we don't have to do this, it's just the way that I like to do it, just so I can verify that things are working. And then we can take this same iterator, bring it over, and essentially what we're going to do is we're going to say key is readable, and then we're going to create a read method like this, and we're going to take in a selection key. Okay, so now we've moved some of this stuff over. We need to basically now bridge these two things together to get kind of back to where we were. So we can basically create a version of this in here. Oops. Server reader. That. Okay. And actually only start this thread. Well, actually, let's put this here. So, so now there's a couple of things we need to do. We need to only say start the server reader, and if we have a new client, so basically we can say if server reader dot. Actually, I don't think you can check to see if this is running. Yeah, you can. So let's just go ahead and do this. Let's just say server reader dot run. Okay. So that's gonna spin up this thread. It's gonna run. It's not gonna do anything for now. But the real important thing though is that we want to, when we're our read operations, we want to happen on server reader dot selector. Okay, so basically our server thread again is only responsible for accepting any new connections, attaching that ID, and then it's going to pass and register that new client on the actual read thread's read selector. So that keeps our server thread to just accepting connections, and then this guy over here is going to actually read, right? And so remember we put that attachment on there. So actually, let's grab that code out of here. There we go. Put this back in here. So basically we're saying client ID is ready for read. So this code now should be in pretty much about the state that we were in. However, I don't remember if this blocks. I don't think it does, but oh, we need to do this. Yeah, we should probably capture this thread. And reader thread equals thread server reader thread dot start, and this actually might be blocking. Causes this thread to begin execution. The result is that two threads are concurrently current thread, which returns the call and the other thread. It is never legal to start a thread more than once, particularly if the thread may not be started. And again, I haven't done this in a long time. So, all right, then the other thing we should do here is always stop and shut down this other stuff. So the reader thread, we can basically interrupt. Yep, so this should stop. And we can say server reader thread stopping. All right, so let's see what that does. I'm a little worried that this start is going to block us here again, but let's take a look here. I don't remember what this behavior is going to be. Server. So let's run this. Let's see what we get. Okay, so the server socket's listening. Let's do this so that we know if this is running. Server reader thread is now running. Let's restart. Okay, so the server reader thread's now running, server socket's listening. And let's go ahead and run the client and see what happens. So that finished, and we're ready for read. Okay, that's a good sign. All right, so let's clean this up a little bit so that we can see better what is actually happening. Okay, so this is actually working, and what I'm going to do here is I'm going to actually put in front of all of these the actual thread name so that we can very easily see what is happening and on what thread it's happening on. So it's listening there, listening there, listening there. All right. So we're going to rerun this again just so that you guys can see what's happening. So we're going to run the server. So again, you'll see we've got two threads, right? So we have a server thread, and we can actually name these. Name these server dot. No, not server. We're going to name the thread server. So we could call this NIO server acceptor. And then we could call this one nope, that's got to be here. Reader thread, NIO server, reader. All right, so now if we rerun this, we'll see the nice thread names, right? So we've got our reader and our acceptor. Okay, so now we have two threads running in parallel, just like we wanted from this diagram. We are always accepting here, and then basically we're passing off any reads to this read selector so that if we're doing a really long read, we're not blocking any other clients from being accepted. So now we're kind of back to where we were. Now let's go ahead and do some reads. So socket. So we're going to take the selection key, we're going to get the channel, and I'll just show you what this is so that we can see it, and we'll block this here. This is going to be a socket that we can actually read from. And we're going to run this guy. Okay, so what is this? This is a socket channel impl. Okay, so we can go ahead, socket channel. All right, and this has all sorts of stuff in it, and we'll get to that in a little bit. But so now we have this socket, and we want to read from it. And what we're going to do for now is we're just going to read and print out. And in the future, what we're going to do is we're just going to make a simple echo server. So this will just echo whatever it came. But let's take a look at the documentation for socket channel. Dun, dun, dun. Let's just open this Java 8 socket channel. Okay, so selectable channel for stream-oriented connecting sockets. Socket channel support non-blocking, and again, remember we set this client to be non-blocking. Okay. Now let's go ahead and take a look at what we have. So we have a bunch of methods that allow us to read, and we're going to use basically reading into these byte buffers. So we need to first create a byte buffer, and you can. This is I'm not going to go too deep into this right now, but basically you can really allocate however much you want. I'm going to say in this case 512. And for now I know that this is going to be more than needed, but again, these things come in chunks. So if someone tries to send you a 1 megabyte file or more data than you have here, you're going to have to create multiple buffers, move things around, chunk your data however you might need. For now, I know that this is going to be enough. So we're just going to use that buffer, right? So we can basically do socket.read. We're going to give it a buffer. And we're going to say the number of bytes read, and we're going to take this, and we're going to say however many bytes read from clients. And we're going to move this because it's not very useful there. Rename this from client. Client ID. Okay. So we're going to read that out, and then we're going to basically print the payload that came from it. And we'll say payload, and we'll put it in brackets. And we want to say, and we know it's going to be a string again. We're glossing over some details here. The message that we got, string, new string, and we can basically take that byte buffer dot I haven't used byte buffers in a really long time either. Buffer dot array. There we go. There we go. I think you can pass this as a char set. Yeah. So we're basically just saying we're going to assume that this is a UTF-8 string, and then we'll put the message in this payload. So that's really it. We're going to pull all that data off again, format it as a string, and read it. Again, for now, this byte buffer, we know this is more than what we are sending. We will deal with multiple buffers later. Okay. All right, so let's run the server again and see what happens. All right. So then we're going to run our client. And we're going to cross our fingers that we see on the server the payload. Okay. So we are getting -1, right? Okay. Basically, we need to be checking if bytes read does not equal or is really greater than 0. Do something else not going to do anything. So we only want to print this message, right, if we actually read some bytes, okay? So we're going to restart the server, and otherwise we'll just fall through. So then we're going to run the client ran. Okay, so that's good. So the NIO server reader, we received 12 bytes from localhost and this other port, and we got our payload, and this says hello server and some garbage. So why is that? When we allocated this byte buffer, we gave it 512 bytes, but we only actually have or got 12 bytes in there. And so what we're doing naively is just putting the entire buffer in there, and that's not going to work. So we can basically take a slice, 0 to bytes read, list byte dot 2 byte array. Again, this is not necessarily efficient, but it just gives you quickly the best idea or an understanding of what's going on, right? So now, and let's just debug this to make sure that we get this right the first time. So we're gonna get this here. Again, we're basically taking our entire buffer, we're slicing it, we're grabbing 0 to 12, and then we're calling 2 byte array on that, and that gives us our message hello server. And so there you go, we have that. And again, this really should be bytes read, 12 bytes read, yeah, 0 minus 1. Range 2, or the call should be replaced with until. This is a Kotlin thing. Will it just fix with 0 until bytes read? Oh, that's kind of cool. So I'm assuming that is the nice, clean, easy way to get item -1. And there we go, our payload, hello server. We can now read a message off of there, and we can now read the data that the client sends. Now, just to make sure that we're not hello server, this is a longer message. Just to see what happens with that, we'll send that message over. We'll close it, and you'll see hello server. This is a longer message, 37 bytes. Okay. Now, what happens when this message is very long? And say it's greater than 512. Well, let's take a look at that. Let's put a really, really, really long message. I don't even know if this is long enough, but basically what we'll do is we'll grab all of this and we'll duplicate it, and then a couple times. Okay, so what's going to happen is this is going to only print out 512 bytes. And if we look at the documentation for read, that's not going to give us what we want. Let's look at the docs for read. Read, right? Reads a sequence of bytes from this channel into the given buffers. An invocation of this method of the form C read behaves in the exact same manner as the other. The number of bytes read, possibly 0 or -1 if the channel has reached end of stream. Now, because we're not reading, typically what you would do here is you would read multiple times until you got -1, and you would continue to, you know, keep a really long buffer. But we'll see here, this still works. We just get truncated at 512. So basically, if this message is long enough, which it should be, we'll see 512 here. We'll see a big long message, but there's still probably a whole lot of stuff at the end. So let's send this message again. Close the client, and from here we're going to see a whole bunch of data. All right, and now this is where, you know, we need to be handling our own kind of buffering per client. So this actually fell through multiple times. So we read 512, finished. The key told us it was readable again. It read 512, read 512, read 512, and went through. So like I said, you have to keep track of the buffers per client in order to capture all of those and know like when you read until the end. So just to illustrate this a little more, we're gonna put this in here, and we'll say, actually, let's do this down here, just so that we can show that this is happening multiple times, because this is pretty important. Client ID, we're gonna say reading from client ID, and we're gonna indent this a little bit so that we can actually see this, because this is happening multiple times, and this is kind of important. So we're gonna clear this just so we can see it better, but we're gonna run the client again, and if we go back to this, what we'll see, what did I do? Oh yeah, we're not gonna be able to see that. This will be better. We need to move this down here. Let's rerun the server again and rerun the clients. So again, we're up and running. We're going to run the client. Client's done. And so you'll see here that basically our reader is happening in multiple chunks, right? So we did a read, we did another read, we did another read, we did another read, right? Because this payload is greater than 512. And so this is what's so important, is that NIO is built and meant to, again, you have to be very careful when you block. So for example, say I made this buffer really large, and didn't let other people through. That would mean that if someone was sending me a really big file, that a whole bunch of other people might be blocked. And so say someone, you know, say something came in and there was basically a 10 megabyte file from client 1. If I didn't do things this way and I just made my byte buffer really large, what would happen is that if anybody else came in that maybe had you know, 50K file from client 2 or a 10K file from client 3, that would be bad, is because I would be sitting here waiting and reading, and I'd be blocking everyone else, right? So in this case, it shares this. So, and right now we're reading in 512 chunks. So that basically means that after we've read 512 of this, we'll be able to read this, and process it right away, and then we'll come right back to this client, right? So again, we want to be able to, we're multiplexing, we want to be able to both accept and read from multiple clients in a single thread, and you know, we need to share the wealth. So so let's go ahead and make this bigger, and you'll see that basically this only happens if we make this big enough, right? We're only going to see this once. So let's rerun the server, and then we're going to rerun the client. And we'll see that again, right, we only had to read once because we had enough bytes in our byte buffer to read the entire thing in, right? So we only read once. So again, we're gonna work on this a little later, where how do we keep track of byte buffers? How do we manage that per client? The client ID that we had is gonna come in handy to do that. But you know, this is a lower level. NIO is a lower level framework. We're gonna have to keep track of these buffers and keep track of the clients that are connected and all that good stuff. And so we're making progress. We made a lot of great progress today. We now have two threads, basically a server thread and a server reader thread. The server is only responsible for accepting. We now have a read thread that is responsible for reading. When the server accepts a new client, we attach that ID so that we can keep track of it, and then basically we register that client on the read thread and say, hey, this thread is responsible for reading any data off of this new client. And then we've basically done a very, very, very naive read method here that basically just reads in chunks of 512 to allow for multiple clients on this single thread without blocking too much. And again, this number is fairly arbitrary right now. It's for testing. This is, I'm sure that there's tons and tons of things. You could tune this to your heart's delight based on your workload, based on the machine or server you run this on, to make things run faster or slower. Again, we're just interested in learning the idea and the patterns behind event loops and NIO. So this doesn't actually have any meaning. But as we go, we might adjust this a little later as we start to accept more connections and as we start to maintain and keep some of our buffers. Because again, this is utilizing memory. So if we allocate a big chunk of memory for every client, that wouldn't be very good. And so we're really going to probably use one buffer that we might declare for the reader that pulls the data off for every client and then copies that data, or at least moves that data in some sort of efficient manner over to the buffer per client, right? So this right now is bad. That this basically says, like, for every incoming client, allocate a new buffer, read into that buffer. That's not what we want. We're gonna fix that later in some later streams. So yeah. So today, we had our to-dos. We now can read from an IO socket, and we can now use a different selector or thread for reading. So I think we got everything accomplished that I want to today. Again, I'm going to check this code in here in a few minutes. It'll be tagged to the correct spots, so you guys can take a look at it and inspect it some more. But I think that's it for today.